All right, this is a short tutorial on Newton's laws and forces. All right, let's jump right into our problem. So we got two forces acting in opposite direction on a box. What's the mass of the box if the acceleration is 4 meters per second? So you got a 50 Newton force acting in that direction and a 30 Newton, we'll say friction force or force acting in the opposite direction. So we need the net force. And so we'll treat this as the positive direction, 50 newtons minus 30 newtons will give us 20 newtons. So that's your net force. Now we just need to find the mass, so we're going to pull out Newton's second law, F equals ma. We know the F, we know the A, so we just need the mass of the box. So mass is equal to force divided by acceleration. So 20 newtons divided by 4.0 meters per second squared. Now the units may look like they don't cancel, but if FA, it's equal to a kilogram times a meter per second because it's mass times acceleration. And then you got 4.0 meters per second squared. The meters per second squared cancel, and you're left with a 5 kilogram box. And that would be your answer. Let's look at another problem. This one's a bit more complicated because we got 3 forces instead of 2. So again, 4 kilogram box, we want to find the net force on that block, and now we're going to find the acceleration in part B. It's a 4 kilogram block. So the net force will be the 25 newtons plus 5 newtons. And this can be minus 10 newtons. So 25 plus 5 is 30, minus 10 is 20 newtons. And then we're again going to use Newton's second law, F equals ma. So this time we're going to find the acceleration. A equals F divided by m, or 20 newtons divided by 4 kilograms will be 5 meters per second squared. And so that would be the answer to B. That is the answer to A. One just bonus problem. A lot of times weight is a force as well. Technically mass is a mass in kilograms is a mass. It's not a force. But a lot of times we equate it to pounds, and that works because gravitation is constant. But if we want to get the weight of an object, we need to find how much force it exerts in newtons. Now, if you remember F equals ma, if we do a slight substitution and say, well, the force that we're exerting is just the weight, then it's equal to the mass times the gravitational constant. If we have an object that has weight, that force vector is always pointing straight down. So if we plug into our equation, we're going to have a 5 kilogram object with a 10 meter per second squared acceleration due to gravity, which would give me a weight of 50 newtons. Now, if I want that in pounds, it's just going to be a little conversion. 50 newtons, there are 4.45 newtons in 1 pound. The newtons cancel. So we're going to say 50 divided by 4.45. And we get 11.2 pounds. And that makes sense. We could have directly converted the kilograms to pounds, but in this case, I want you to see the conversion between newtons and pounds. So 11.2 pounds. This has been a brief tutorial on Newton's laws and force.